Students, in this video, I will discuss interference of wave. What is the interference of wave? When two or more than two waves travels in a medium simultaneously, that somewhere intensity becomes maximum and somewhere intensity becomes minimum. This phenomena is called interference of light. Interference of light. Interference. When two or more than two waves travels in a medium simultaneously, somewhere intensity become maximum, becomes maximum, and somewhere intensity become minimum. Intensity becomes minimum. This phenomena is called interference of light. Interference of light. When two or more than two waves travels in a medium simultaneously, that at some points in the region intensity becomes maximum and at some point intensity becomes minimum. This phenomena is called as interference. Now I prove it mathematically. For this, I take two waves. Let two waves. First is y1 equal to a1 sine omega t and y2 equal to a2 sine omega t plus phi travels in a medium simultaneously. So, by the principle of superposition, the resultant displacement will be equal to, or resultant wave will be equal to y1 plus y2. Now, put the values of y1 and y2 and solve. Y1 I have told you a1 sine omega t plus y2 a2 sine omega t plus phi. That is, now y equal to a1 sine omega t plus a2. Solve this by sine A plus B formula. That is sine A means sine omega t cos B cos phi plus cos A sine B, like this. Sine omega t cos phi plus cos omega t sine phi. Now A1 sine omega t plus A2 sine omega t cos phi plus A2 cos omega t sine phi. Now again A1 sine omega t plus, I take common here, A sine omega t take common here, you will get A1 plus A2 cos phi sine omega t plus A2 sine phi cos omega t. Now I suppose let A1 plus A2 cos phi equal to A cos theta, equation number 1, and A2 sine phi equal to A sine theta, equation number 2. This I consider and I put in place of A1 plus A2 cos phi A cos theta, and in place of A2 sine phi equal to A sine theta. So what we get? That is y equal to A cos theta sine omega t plus A sine theta cos omega t. Y equal to, I take common A, you will get A sine omega t cos theta plus cos omega t sine theta. Now, what is the formula? Sine A cos B plus cos A sine B. Now this is reduced to formula omega t plus theta. What you get? It means when two waves merges, the resultant is also a wave. I have told you now. I have proved you that resultant is also the resultant of two waves is also a wave. Now, I have to prove that intensity is somewhere maximum and intensity is somewhere minimum. I take the help of these two equations, A1 plus A2 cos phi and A2 sine phi. Now what I do? Squaring and adding. Squaring and adding equation first and second. What will you get? That is A square cos square theta plus A square sine square theta equal to A1 plus A2 cos phi square, this square plus this square, plus A2 sine phi square means this square. Take common A square, you get cos square theta plus sine square theta equal to what? A1 square plus A2 square cos square phi plus 2A1 A2 cos phi plus this A2 sine square phi. Now this is 1, so we get A square. Now A1 square, I take common from here, A2 square cos square phi plus sine square phi equal plus 2A1 A2 cos phi. What you get again? This is 1. A square equal to A1 square plus A2 square plus 2A1 A2 cos phi. Now, the resultant amplitude. This A is the amplitude of the wave. The resultant amplitude of the wave is this. Now, the intensity of a wave is directly proportional to the amplitude square. This is the amplitude A. Now I can write K A square, inserting a constant K. Put the value of A square here. The resultant intensity will be K into A1 square plus A2 square plus 2A1 A2 cos phi. This. Now, I have to prove this is the resultant intensity caused by two waves at one point. Now, A1 is constant, A2 is constant, this is constant, only variable is phi. Now, intensity will be maximum, intensity will be maximum when value of cos phi is maximum. And you know cos phi, value of cos phi maximum equal to plus 1. And this is possible only when phi equal to 2m pi, where m equal to 0, 1, 2 like this. So, where the phase difference phi is 2m pi, the intensity will be maximum, and we will say that interference is constructive. Interference is maximum or interference is constructive. Interference is constructive. This. And maximum intensity will be, I max will be A1 square plus A2 square plus 2A1 A2, and maximum value of cos phi is 1. So maximum intensity K equal to A1 plus A2 to the whole square. This is the maximum intensity. At the points where the phase difference between the two waves is 2m pi. Now, I again, the intensity will be minimum, intensity will be minimum when value of cos phi is minimum, means minus 1. And this is possible only when this is equal to 2m plus 1 pi. And this is possible only when m equal to 0, 1, 2, 3. At the points where the phase difference is 2m plus 1 pi, then intensity will be minimum. Minimum intensity, and we may say that interference is destructive. Interference is destructive. Destructive. Now, minimum intensity, I minimum equal to A1 is K, A1 square plus A2 square plus 2 A1 A2 cos phi value minus 1. So, I minimum equal to K A1 minus A2 to the whole square. This is the formula for the minimum intensity. So, I have shown here that when two or more than two waves travels in a medium simultaneously, that somewhere intensity is minimum and somewhere intensity is maximum, or this is the phenomena of interference. Where the intensity is minimum, the interference is said to be constructive. Now, where the intensity is minimum, the interference is said to be destructive, and where the intensity is maximum, the interference is said to be constructive. Okay.